Hey, so we're talking about inverse variation today. We talked about direct variation earlier in the year. So first we're going to figure out what are examples of inverse variation and what are examples of direct variation. So inverse variation will always look like either of these two equations. Pay attention that the first equation has x on the denominator. So as long as x is in the denominator, it's inverse variation. If that's a number or a y instead of x, then it's going to be direct. And then we also have x times y equals some number is also an example of inverse variation. Direct variation will look like this, where it's y equals some number times x. So k is just some number, we don't know what it is. So for number one, let's first check inverse variation. So inverse variation looks like this typically. This is what we use more often than the fraction one. So this means x times y value is going to give you some number. We want it to always be the same number. So 1 times 16, that's 16. 2 times 8 is 16. And 4 times 4 is 16. Since those were all constant, that means it's going to be inverse variation because it works for that inverse variation equation that I put at the top. So let's try it again with number 2. So again, we're trying the inverse variation. So 1 times 3 is 3. 2 times 6 is 12. Not the same, so that means it's going to be direct variation. And these numbers will actually work in the direct variation equation. So for example, if we plugged in 1 and 3 into this equation, which is direct variation, you get 3 equals k times 1. So k would be 3. And then try again with 2 and 6. So 6 equals 2 times k, so k equals 3 again. And then 9 equals 3k, k equals 3 again. So since k was all the same with the direct variation equation, that's why it's direct variation. But as long as you notice that it's not the same when you try inverse, that means it's direct. Number 3 and 4, we have equations instead of tables. So we need to match it up to one of these three equations. So if I look at number 3, it says x equals 2y. What I'm going to choose to do is get y by itself because 2 out of my 3 equations up here have y by itself. So to do that, we divide both sides by 2. So we get x over 2 equals y. But this x over 2 is actually the same thing as 1 half x. The reason for that is because there's that invisible 1 in front, so I can clearly see 1 half. Then I have this x. So this says y equals some number times x, which is what direct variation says. Y equals some number times x. So this is direct variation. You also could have taken this equation x equals 2y and divided by 2. Same thing we did already. Notice that I have a 2 in my denominator. For inverse variation, I needed an x in my denominator, so they didn't match up. Number 4, I'm going to get rid of this 2 by dividing by 2. So we get xy equals 5. So this already looks like inverse variation because inverse variation right here, x times y equals some number. I have x times y equals some number. So this is inverse. Okay, moving down. Okay, now these next two problems, just the directions sound really complicated, but they're not that bad. It says assume that y varies inversely as x, y is 18, x is 2, write an inverse variation equation that relates x and y. So since they say use an inverse variation equation, I'm going to use this equation because this was my inverse equation. So I'm going to plug these numbers in. So x was 2, y was 18, don't know what k is. 2 times 18 is 36. So k equals 36. But that doesn't exactly answer my question. They wanted me to write this equation. So what you do is start back at your original equation. Since I know that k is 36, just plug in 36 and that's your answer. So this would work if they said, okay, x is this, what is y? You could quickly figure it out. Now, we could also do that a little differently with a product rule. So I'm going to use this equation right here. This is saying one coordinate, so one x value and one y value that paired together is equal to another pair or coordinate that pairs together. So we want to make sure that the coordinate that pair together is going to stay together. So y equals 3 and x equals 12, they go together. And then we don't know what x is when y equals 4, so they go together. So on the left side, I'm going to multiply my first points together, so 12 times 3 equals, and then multiply these together, so 4 times x. So 12 times 3 is 36. So that means x would be 9. And you also could have gotten that using this process up here, figure out what k would be, plug it in, and just plug in one of your values. But if you just multiply one coordinate together on one side and one coordinate together on the other side and solve it, you'll get the same answer. So now you have your homework, just the Monday section. If you have any questions, feel free to email me.